Testing 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Aubrey, first off, thanks for doing this. You are a fossil preparer.
Correct.
What are you preparing?
This is a small herbivorous dinosaur that came out of the Mustntucket Formation in Utah.
Oh, okay. So we don't know what kind of dinosaur it is.
Correct. It has to be prepared before our researchers can take a look at it and see exactly what's what.
What's the nice shirt, by the way? I just noticed
Thank
that.
you.
Very cool. How do you do this?
So we find the dinosaurs out in the field. We wrap them in this lovely white plaster jacket to keep them safe. They get packed up and brought back to the lab, and then there's still all of this rock, this light gray surface covering the bones. This nice black stuff is what we're trying to get at, the skeleton. And so I have my pin vise and my brush, and I work all the rock away.
That takes forever.
Forever, yes.
You've got to have incredible amounts of patience.
For sure. It's a really rewarding process, though, watching the rocks flake away from the bones.
Why?
There's just something, I don't know, I just think that they're pretty.
And so how do you know which is, I'm assuming that the bone is darker than the rock.
Correct. At this locality, the matrix is this kind of light gray, and then the bone is a dark brown, almost black color, but that depends on where you're working. Different minerals in the matrix will change, like the fossilization, and the bones can be a different color, from anywhere from white to kind of purplish, brown, black.
Do you worry that as you're flecking away, you suddenly are going to destroy something that's, hundreds of millions of years old, or is that just a...
I have glue for that.
Very good. Okay, you just be real careful and real patient.
Really carefully up. The scope helps. You're zoomed in really, really close to the bone so you can see really well what you're doing. If something does break, because these things are fragile, we have consolidants, and you line the pieces back up together, and they're good as new.
Okay. Is it cool? I would think it is. As you're looking away and you're seeing more and more of this, you start thinking, wow, what is this creature like?
Very much so. Yeah, that's one of the reasons that it's so rewarding is, uncovering a skeleton that nobody has seen in millions of years.
Thank you. That was great.
Ready? Go. Give me one more. Leave it there for a little bit.
When you move your finger up and down and kind of between the brown and the darker.
There you go. Perfect. Thank you.
sound file 5.
I hate to say, I hate to ask what you're doing. I think I know, but what are you doing?
I'm puzzling, basically. I'm trying to get all these pieces back together. So we've got boxes of little fragments that we know were collected all from the same site, and I'm trying to reconstruct as much of it as possible, so we end up with hopefully less little boxes of pieces.
And how do you do that? Just color, texture?
Color, texture, shape, anything that helps me make connections.
Let me ask that one more time, because you started to talk while I was still talking. How do you do that?
Look for color, shape, size, anything that will help me make connections between the pieces.
And how do you know, you kind of alluded to it, how do you know that they go with those bones?
Yep, so all the pieces were collected from the same area. So we know pretty well that these all come from the same site.
And you said, so any success so
Yes, been able to reconstruct quite a bit of it, although we still have many, many pieces that may or may not, just how they broke may or may not be able to go back together.
And so what are you, is it a leg, that's a leg bone, I'm assuming. What is the one you constructed here? Is that leg
That's
also?
part of the leg here. Yeah, most of these are part of the lower limb of a dinosaur. But there is, a whole bunch of different pieces. They could be from different parts of the body of this animal. And so we just got to try to get them as much back together as possible.
Okay. You're not going to throw any of that away, I'm assuming?
No.
It could be still valuable.
We're not going to throw any of it away because they all add information. It's all data to this particular specimen, so we won't get rid of anything.
Okay. So you're thinking, oh, okay. Yeah. Yeah. Okay. So you've looked at everything and you're thinking, well, this might go here, and so you put it in and see if it fits?
Exactly. So it's spent a lot of time staring at these pieces, making mental notes of different colors, shapes, interior bone texture, and I'll pick up a piece and I'll spin it around in my fingers, and then something in my mind will be like, oh, maybe this will go here.
Okay.
So I'll try to go back and fit it together. Sometimes I'm right, sometimes it just doesn't work out, but that's what I'm doing.
And then when you leave here, you go home and do puzzles, I'm assuming.
I actually don't. I leave the puzzling for work.
It's got to be fascinating that you're still holding something hundreds of millions of years old that might go there.
Yes, yeah, it's great to be able to take something that was broken by the collection processes or by natural processes in the field and be able to put it back together and take a small fragment and make a more whole bone.
Great, perfect, thank you.
Yeah.
That was excellent. Just keep doing what you're doing.
right hand, so your left hand, yeah. One more time, take a breath, and go. Just hold it there. Yeah, you're just looking at it over. Take it away. That was great, thank you very much.
Sound file 6.
Okay. Do a sound check. All good? All right.
Sounds good, thank you. All right, good. Okay, so it's basic question first off. What are we looking at here? Two different fossils.
Yeah, so see, these are some of the prepared specimens that have been collected by museum researchers. So we have one from the local Triassic of North Carolina, a phytosaur, and then a skull of a large horned dinosaur, Triceratops, from the late Cretaceous of Montana.
I'm looking at them. Colors are different. Remember last week you said the bone is usually darker than the surrounding matrix usually. But explain the color. What's going on here?
So that was only at the site that we were working at. So the bone color will differ in basically every site you go to. So, and it's entirely dependent on the rock or the sediment that it was preserved in. So for example, the phytosaur here, this is in these really red, classic Triassic kind of brick red colors. And that's because this is in an oxidative regime. So basically iron, the metal iron gets absorbed into the fossil as it's being fossilized and then rusts. So you have that sort of rusty red color to the phytosaur fossil, entirely different sort of chemical systems during fossilization for the dinosaur, which is in a very different environment many millions of years later. So different colors to the fossil, they're found in different types of rocks.
Same fossilization process, just affected by the surrounding minerals and what's in the soil.
Exactly. So for all of these animals, you know, they died, they were buried in sediment, and then over time that sediment leached into the bone through the pores in the bone. And then over millions of years of compression, the sediment was turned into rock. It was lithified, and the bone that is in that rock is fossilized. So it's also turned into rock in a way.
Okay, and you've got a bone that we found last week.
Yeah. So this is the claw of the Dinosauriodont, which we collected when we were just out in the field. And it's received some preliminary prep, so you can see it's now this bright white bone color. It's actually quite different from as you see it in the field. So a lot of times, not only new anatomy, but sort of new understanding of the fossilization process can happen once the specimen has been prepared.
All right, so from when we saw it last week to now, anything new you can glean from that, or put you on the spot there? Sorry about that.
Yeah, no, I mean, it is a few things. So in the field, it was covered in that greenish crust, and now we can see the white bone underneath. And so we can actually see those two little holes, which were covered in sediment when we first found it. Those are where the muscles and the ligaments attach. So we can understand a little bit about how this would have fit onto the hand of the Dinosauriodont. Also, now that we know for sure what shape it is, it's basically the same shape, but you can never be totally sure when it still has the matrix on it. We can see that it's a very, very broad, very flat bone, and so it would have been covered in a hoof in life and probably used for digging in these animals.
You can tell all that just from that. Oh my gosh.
Well, I mean, it's all informed speculation, at least. But you can see it has it's flattened and sort of concave, so it's very like a trowel. And so the shape of these things, you know, there are reasons why our tools have certain shapes and why nature has evolved towards those shapes as well. It's for similar goals.
That's perfect. Awesome. Thank you.
Mm-hmm.
Very cool. Okay, so.
There you go, anytime.
All right. Yeah, so this is the ungule. So this is the claw bone of the Dinosauriodont that we collected just the other day out in the field. So it's since received some preparation. And so it's cleared off that matrix, the surrounding rock, and exposed the actual bone underneath. And so one thing that's interesting is, you know, in the field it was darker than the surrounding matrix. It was that really dark green color. You can still see a bit of that there. But here the bone itself is actually really nice white bone. Very good bone quality. And there's actually a few things that we've learned about the anatomy of this already. So we can see both more about the shape of the bone, and we can also see these depressions, these little holes in the bone. So these would have been attachment sites where it would have basically connective tissue would have connected the claw with the rest of the finger bones. Can also tell some things even about the lifestyle, or at least speculate as the lifestyle of this animal, because it has this very sort of flattened and curved morphology, the shape to it that we think would have been useful for digging. So you can see how sort of flattened it is, and it's also sort of concave a bit inside. So this is,
So it's kind of like a trowel.
yeah, exactly.
So how would you use that? Then? You would really
The
good.
more you can hold it in one area, that'd be great. Just
Okay.
rotate it around.
Yeah, sorry. Yeah, so I mean, you can think of it a lot like a shovel or a trowel. So it would have been using, it would have been covered in a hoof in life, but basically we've been using these to dig through the sediment. So very similar, to the tools that we use for digging. Human tools in many ways kind of mirror what nature has already created. So a lot of convergence there.
Just rotate it around with the B-roll.
Yeah.
That's cover everything. Yeah, that's perfect.
All right, great, cool.
No, these are the old ones. These are the ones. No, I thought you were talking about the one on the, that's my personal one. Yeah. It's a sweet pick. Oh, wow, yeah, that's how that's how you go down.
Yeah,
It's a third of the price.
the mics are probably a little more expensive.
Horsetails and tree ferns. All that lots. This is before there were any flowering plants in that fall. Just started to get conifers. Yes. I mean, there are a lot of groups of ferns that evolve later, but like tree ferns nowadays, you only get a prehistoric aspect in New Zealand, in like Brazil, in New Guinea, and places that still have a lot of tree ferns in the forests. There are still like fully tree ferns, woody ferns that still exist in a few places inside of Australia. Horsetails, there are only small. So in the West, there were giant horsetails, cavaliers, that would get, my brands, to around 12 to 15,000 years ago, they went extinct. So they came up actually, and especially from South America, sloths, classically Amazonian, or Andean, things like jaguars and llamas, those are all from North America and relatively recent immigrants to South America.
Any more samples or fossils in here?
Yeah, just fossils in there.
More. Shipped by Delta. There we go.
Yeah, there was an expedition last September to Mongolia that some of the people from the lab were involved in. One of them is, well, one of the postdocs, perfect bone quality. Very easy to prep. It's very soft sandstone.
Oh, okay.
Not all like this.
You know, your hometown museum, shall we speak, just what all they do. It's so fascinating. You just don't realize.
Anything else here, Frank?